Here's some more symbols. Line segment AB is 5 feet. Line segment CD is 5 feet. Therefore, we say that line segment is congruent to line segment AB is congruent to line segment CD. This is a simple symbol for congruence, congruent of the same measure. That's what it means. They have the same measurement. This also, without writing the numbers, tells the reader that they have the same measure, the same number of tape marks. If this had 2 tape marks and this one had 1, we would understand they were of the same measurement. But since they have the same number of tape marks, line segment AB is congruent to line segment CD. They have the same measure. Right here we have angles. So these 2 angles are equal of measurement, right? Angle A and angle B. So we say angle A is congruent to angle B because they measure the same amount. Notice here, angle B and angle E are congruent because they measure the same amount. Or if you don't put any numbers, if you just put an arc, the ones that have the same number of arcs are supposed to be taken as equal in measurement. If this one had 1 arc and this one had 2 arcs, I would understand they don't have the same measurement. Regular polygons. The word regular means that all the sides are congruent and all the angles are congruent. So 2 things. The sides are congruent, all of them, and all the angles are congruent. That makes it a regular polygon. Triangles. An acute triangle has all its angles on the inside acute, greater than 0 but less than 90 degrees. Right angle has 190-degree angle. An obtuse and a right triangle has 1 right angle. An obtuse triangle has one obtuse angle. Now we're looking at some of the markings. Notice these markings tell us that the sides are all of the same measure. These markings of the angles, that means all the angles of the same measure. You could call this an equilateral triangle, or you could call it an equal angular triangle. Notice the markings tell us that all the sides are of a different length. This triangle is called a scalene triangle. Then an isosceles triangle has at least 2 congruent sides. And since it has 2 congruent sides, it should have 2 congruent angles. That's an isosceles triangle. Quadrilaterals. So we have quadrilaterals, that's a 4-sided polygon. And you put a restriction of the opposite sides being parallel, and look at the symbol for parallel, these little arrows, the ones that have the same number of arrows in between are to be taken parallel. So these 2 are parallel, these 2 sides, and these 2 sides are parallel. That's why we call it a parallelogram. Now a parallelogram, if you tag on 90-degree angles, then that parallelogram would be called a rectangle. And if you get a parallelogram and just make sure that all the sides are congruent, you could call that a rhombus. Now, if you put all the characteristics that came before on one figure, you would have a square. These are other quadrilaterals. Notice there's 4 sides to each of these figures. A trapezoid has at least a pair of parallel sides. And these 2 are kites. Notice the kites have congruent, adjacent, consecutive sides. So these are consecutive sides, one after the other. They're congruent. This side is consecutive to this side. They're consecutive sides, and they're congruent. Notice this one. This is a concave kite, right? This is a convex kite because of the cave here, concave. Again, the same reason that they're called kites. 2 pairs of consecutive sides are congruent. We have also types of symmetry. These are the idea of symmetry. The idea of symmetry has to do with matching. You could match across a line, which is like a mirror. You could match the image and the pre-image, matching across a mirror. Symmetry, turn symmetry is turn until it matches. Point symmetry is when you turn it 180 degrees and it matches. Node turn symmetry is also called rotational symmetry. Here are some examples. How many lines of symmetry does each figure have? Well, this one, each one of these broken lines is a line of symmetry. Just take any one you like, and it acts like a mirror. For example, this one, this vertical one, this side is like a reflection of this side. The left side and the right side have this line as a line of symmetry, so it's like a reflection. And if you count them, you could do that with 6 different lines. There's 6 lines of symmetry for this figure. Notice this one just has one, because if you put a mirror here, this is the only place the left and the right would look exactly the same. So there's one line of symmetry. This one doesn't have any. How many turn symmetries does the figure have? So you just imagine this is a bolt and you're like screwing it on like this. You could move this one up here and this one up here, and it would seem like you never moved it, because the original and the final positions look exactly the same. Right here, what you would be asked is, what are the turn symmetries? Well, you first find the first one. If I move this point to this point, and I look back, it looks like I didn't move it, and that was 60 degrees. What I did is I took 360 and divided by 6 sides, so each of these is worth 60. So the first one is the one the rest are going to be based on. So the first turn symmetry is 60 for this figure. If you want to find the other turn symmetries, just find multiples of 60. So 60 times 2, 60 times 3, 60 times 4, 60 times 5. Where do you stop? Well, you can hit 360. So all the ones that came before 360 are going to be the ones that are going to be called the turn symmetries. More about angles. Anytime you cross 2 lines, you're going to form angles, the ones that are looking at each other, that are always equal. These angles are called vertical angles. Angle 1 and angle 3 are vertical angles. Angle 2 and angle 4 are vertical angles. And what's so special about them? They're always equal. So if this was like 60, this was like 101 degrees, this would be 101 degrees. Vertical angles are always congruent. Parallel lines, we've seen those before. Line 1, line 2. If we say they're parallel, they'll never cross each other. But how do you know the lines are parallel? They look parallel, but how do you assure that they are? Well, you draw a line over them or a segment over them, and it produces other angles that are going to let us know whether these 2 lines are parallel. Notice after I put this extra line or segment, this is a transversal, all these angles appeared. So we have 3 types of angles that are produced. Angle 1 and angle 5. Notice this was on the top over here, and this was on the top of this line on the same side of the transversal. These are called corresponding angles. 3 and 7 are corresponding. 2 and 6, 4 and 8 are corresponding. Alternate interior, well, interior means between the 2 parallel lines. Alternate, that means that they go on one side and the other. So angle 3 and 6 are alternate interior. Angle 4 and 5 are alternate interior. Parallel lines. If line 1 is parallel to line 2, then corresponding angles are equal, or they're congruent. If line 1 is parallel to line 2, then alternate interior angles are equal. We have one more type of angle when we have parallel lines, and these are like 3 and 5. Those are same-sided. They're on the same side of the transversal. Same-sided interior, that means they're between the 2 parallel lines. So 3 and 5 are same-sided interior. 4 and 6 are same-sided interior. And if the lines were parallel, then same-sided interior angles would add up to 180. angle 3 plus angle 5, those measurements would add up to 180. The measurement of angle 4 plus the measurement of angle 6 would be 180.